We're now turning to Chapter 7 in the independent t-test, very commonly used inferential procedure. To introduce it, we'll first talk about hypothesis testing.
In conducting experiments, we usually have a research hypothesis that states what we believe the relationship between the variables will be. However, we test the null hypothesis with statistics. The alternative hypothesis is generally the research hypothesis. So our procedure now is to obtain the data, analyze it statistically, and make a decision based upon probability.
And that probability falls back to looking at the normal distribution. Remember those z-scores outside 1.96. Here's an independent t-test. Think about this model. We have two groups. We have two groups only, and they are independent. Independent in the sense that if you're in one group, you're not in the other group. So it might be things like boys and girls, experimental and control, active sedentary, smoker, non-smoker, even alive and dead would be independent groups. So let's take a look at some hypotheses and some distributions that illustrate the t-test.
Here's an illustration of the null hypothesis.
Here's the value for men. Here's the distribution with a mean value. If the null hypothesis is true, what would the distribution look like for women?
Their mean score would be identical to the men's mean score.
And if you subtracted the men's mean from the women's mean, you would get 0. Where's 0 on a normal distribution? It's in the middle.
So what about our alternative hypothesis? What would it look like?
Here's the distribution for men. And if the alternative hypothesis is accurate, the distribution for the women would be something different. That's to say that the mean difference between the men and the women is not 0.
Let's look at it a different way. Here's another illustration of the same thing.
We have experimental and control groups. Do they differ on a dependent variable? If you take a look, they do not differ. That's to say the null hypothesis accurately reflects that there is no difference between the experimental and control group on whatever the outcome or dependent variable might be. Let's take a look at a different example. How about this one? Is there something going on here?
The means are different, but are they significantly different?
And in fact, if you'll notice, the experimental group mean tends to be just somewhat in the tail of the control group. How about this one? Anything happening here? We have an experimental group and a control group. Let's see. The difference between the means is very large. So there must be something going on here. Let's take an example with some real numbers now. Here's an independent t-test. We have 100 girls and 100 boys. We have their performance on curl-up achievement. The mean for the girls
is 48.68.
and that for the boys is 63. Are those significantly different? That is there a relationship between gender and curl-up scores?
When we calculate the t value, it turns out to equal 10.07, and we have 198 degrees of freedom, n1 plus n2 minus 2, and the probability of this event, a mean difference of 63 and 48, is less than 0.001 if the null hypothesis is actually true.
So it's very unlikely that you would get a difference of 48 to 63, about 15 curl-ups, if in fact they are equivalent. Think back to our critical value now. The critical value in this case is about 1.96 with 198 degrees of freedom. So you would reject the null hypothesis and conclude that there is a mean difference between boys and girls. That is, there's a relationship between your gender and how many curl-ups you can do.
Now let's look at an SPSS example.
And then we'll show you how to actually conduct this with SPSS. In this case, we want to know whether boys and girls differ on PACER achievement. So notice we have 100 girls and 100 boys, and the mean difference is about 2 laps on the PACER. So we're going to test this with a t-test. The bottom table illustrates the results from a t-test from SPSS. Again, we'll illustrate how to do this with SPSS in just a moment.
Now remember, one of the assumptions of the t-test is that the variances of the two groups are equal. There's a test for that SPSS does called Levine. The red box shows here that that is not significant, not a significant difference between the variances.
The important piece then is to interpret what's in the box now. We have a t-value. The t is negative 0.909. Remember, what was the critical t? About 1.96.
You'll notice the significance level is 0.364. What this means is that this event, a mean difference of 2, would happen 36% of the time by chance if the null hypothesis is actually true.
Importantly, SPSS doesn't list the word probability. It presents it as significance. It has significance two-tailed. More about the two-tailed and one-tailed test will come up later for you. But importantly, that significance is the probability.
In other words, 0.36 is greater than 0.05. Therefore, we're going to conclude that the null hypothesis is true.
We'll now illustrate how we obtained the previous output from SPSS with an independent t-test.
Here's our data set. It contains 100 females and 100 males.
Go to Analyze, down to Compare Means, over to Independent Samples t-test. You now get a window called Independent Samples t-test. The test variables, or the dependent variable, is pacer. The grouping variable, I wish SPSS called it the independent variable, is sex. SPSS requires us then to define the groups. So our groups are defined as 0 and 1. We'll continue, then OK. We have set it up where the dependent variable is pacer lapse and sex is the independent variable. Here now you see the results that we saw on the previous slides. At the top we have the group differences. There's 100 females and 100 males, the mean for the females, mean for the males. Here's our Levine's test of equal variances. Remember, equality of variance was one of the assumptions for the t-test. And then here are our results of the t-test with its degrees of freedom and associated significance or probability value. Interestingly, if you look far on the right, there also is information here about the 95% confidence interval. Notice the 95% confidence interval for testing whether or not these means are equivalent. If the means are equivalent, the value would be 0. Notice that the 95% confidence interval captures the value of 0. That's to say, these boys and girls do equivalent numbers of pacer laps, and the difference between 31 and 33 simply can be attributed to chance.